Good afternoon. Today we'll be presenting you the final phase of Capstone 2 of the SAE Baja. The members of this project are Gabriel J. Colón Ortiz, Anthony Peña, José A. Borges Burgos. We present the authorization to continue with the final phase. In this presentation, we will be discussing the following topics: system validation, overall project conclusions, and overall project recommendation. In the following slide, we'll be presenting in detail each MOP of each subsystem, in which it will be analyzed when the validation type is completed and if it tested or was rejected. The first MOP double check is from the chassis subsystem. The road case must be 50 inches less in inches wide. This MOP was completed in phase C1 and it was approved. The second MOP is from the chassis subsystem, is the most withstand a fall from a height of 6 feet and a roll of 30 degrees. It was completed in phase C1 and it was approved. The third MOP is from the chassis subsystem. Secondary members minimum wall thickness of 0.035 inches and minimal outside diameter of 1 inches. It was completed in phase C1 and it was approved.
Hello, my name is Anthony Peña, and I continue with the system verification. The next MOP to verify if the steering members may no longer than 40 inches. And this MOP is complete in phase C1 and pass. On the right is the most longer dimension is 32.16 inches and continue. Okay. Bend members maybe not have bend rig than 30 degrees. This MOP completed in the C1 and this pass. The right is the angle. Continue. People between 5 feet and 2 inches and 6 feet and 4 inches tall and 130 to 250 pounds in weight. Pace complete in phase C1 pass. Okay, continue. The powertrain wires must be consistent or 661 T6 aluminum. Phase C1 pass. This case is consistent. Dry shaft shall be contained from fabricated via 2 drive shaft hub, weight 51 millimeters of 1/3 length points and 2/3 length points. This MOP is complete in phase 1 pass, and this is the dimension is 1 inches. is 2 inches. Sorry. The dry shaft hubs shall be minimum of 1 inch wide, meaning the same material requirement. The phase 1 complete, C1 complete and pass. The dimension is 1 inches. The next MOP is the powertrain system must be able with the total weight of 1,000 pounds maximum. This MOP complete in phase C1 and pass. In this case, is the mass of car. The maximum capacity for the car is 725 pounds. Preliminary hydraulic braking system shall add on four-wheel with the single foot pedal. Phase 1 is complete and pass. In the right is the picture for the pedal.
Good afternoon, my name is Jose Borges, and today I will be presenting phase F of our Capstone project. For the system verification of the braking system, the 13 MOP is that a 5/8 inches master cylinder shall be operated directly by the paddle. In phase C1, we designed a mounting box to assemble the master cylinder and the paddle. Also in phase C1, the correct calculations were made to make sure the 5/8 inch master cylinder provided the necessary force to the caliper to make the car stop at maximum velocity. The 14 MOP verified was the brake system 7.5 inch disc must be able to lock all wheels in rough competition conditions. The calculations made prove that the disc will function properly with this diameter. Also, a heat distribution test was conducted to verify the material properties. We can observe the heat distribution image here at the bottom of the page, at the bottom right. The 15th MOP verified was the components material shall be steel or aluminum and shall withstand 450 pounds or 2,000 Newton paddle force. The paddle was designed in aluminum and the stress test conducted proved that the paddle will withstand the 450 pounds. We can observe the stress test at the bottom right and top right. The 16 MOP verified was the 1/4 inch brake lines should be placed securely and shall not interfere with suspension or steering. When the whole system was assembled, the brake lines were not touching any components of the car other than the caliper and the master cylinder's fitting. The 17th MOP verified is lines material should withstand the pressure created by the paddle and must be compatible with the brake fluid used. The calculations made show the pressure made by the fluid compressed was way below the maximum pressure supported by the lines. The material also was compatible with the DOT4 brake fluid to prevent corrosion. Here we have the overall project conclusions. We designed and assembled a Baja in SolidWorks. We divided the project into 3 subsystems that were chassis, powertrain, and brake system. We used a lot of information as reference to complete our project final design. We then used all the engineering components and analysis to prove our Baja will perform properly and will be able to compete at the highest level with other universities around the world. Finally, we can recommend to future teams to complete phases and keep adding all the information to the final report. Also, implementing a four-wheel drive will cause a better performance of the SAE Mini Baja. In our case, we could not manufacture the Baja, but another recommendation will be for the other groups to manufacture it so the validation process can be completed. That's all we have for our Phase F presentation. Thanks for your time.